Hello everyone, welcome to Engineering Mathematics. This is an online class which has been recorded for my students. Under the coronavirus disease COVID-19, we have encountered quite different situations unlike normal semesters. So anyway, as we have prepared our classes like this online class, so I'd like to start with my engineering mathematics classes for the first time. All right. Even though we are not so familiar with this environment, but I like to show you my materials like this. Thanks to engineering mathematics, which has been designed for general engineering students, normally sophomore students. Some students are engaged in from the different majors. In that case, they are going to be the junior students mostly. So anyway, this engineering math will covers many things about, especially on differential equations. Though I would like to start my self-introduction. My name is Kang Hyun Jo, for professors of School of Electrical Engineering of the University of Busan. I have served in many different places, in academic area, academic society. So this is a brief introduction to myself. You may see in my online class materials through the U-class, which has been called U-class. And also I have already broadcasted from my neighbor band account, so you have witnessed that things like something like this. So there you may see these U-class materials like this, and band, as I mentioned, you may have already seen this. Materials already, so probably you have already acquainted for a few posts which I have broadcasted so a couple of weeks ago. So anyway, with this material, I would like to keep on my classes. So probably here. I'm sorry, I'm also not so acquainted with this environment. So this is my self-introduction. I haven't worked in University of Busan for a long time. So these are my careers. I have worked in different societies, which is called IEEE, especially Industrial Electronics Society, where I have worked as a secretary until the end of the last year. And also I have worked in many other societies like SAIS from Japan and ICROS in Korea. Currently I'm working as a vice president of there. I have also engaged in many international academic activities like ICIC conferences until now. And I'm working as a faculty dean of this School of Electrical Engineering from this year. And I have served as a CEO or CTO of the corporate incorporations since 2019, 2 years ago. So mainly I have been working in computer vision and artificial intelligence systems. So these are my brief records. So what are we going to learn from this advanced engineering mathematics? So we are going to start with basic concepts of functions and some basic concepts of functionality, and also basic ideas of light on the equations, and so many pieces and bits too. So probably it is easy sometimes when you are using some materials like this. Okay, so for example, so anyway, this is our textbook. This is our textbook, uh, Advanced Engineering Mathematics, entitled Advanced Engineering Mathematics, written by Professor Erwin Kreisy. This is a 10th edition. 10th edition. So most of the nowadays actually the learning process is very interesting. So everything when you encounter something happen, unidentified or unknown, you can search it from Google or some other neighbor searching machines, searching engine. So anyway, those things are going to be used anyway. In this class, I'd like to emphasize your class. Actually, this is online class, so you are not going to be attend on time though. So actually, that is not so much necessary. I rather say uh, you can be much more free access to the materials while we are taking these online classes. If you are going to stay on offline physical classrooms, then you of course have to be appear on time. And also sometimes I will give you some reports, I mean uh, assignments. Then you are going to prepare some documents as a report on A4 page, and also one problem set in a one page. Of course, they should be on time. These are very important when you're preparing materials. That's important. Yeah, that is a normal one. So, and also, as we are broadcasting or uploading some online class materials like this video, those are going to be appear on the our university class online class systems, and also I will ban it. I will put it up on the band. So I have already asked you to have a self-introductions as a icebreaking, and also we have to have an interactive discussion. So I think that is very important. I emphasize this, so you must prepare it. And one more thing is we are going to use computer systems, computer environments, so you are going to use a much more interesting form to work on the materials in an internet or online or digital platforms. Sometimes you are going to use online software programming usable. For example, Wolfram's Mathematica or MathWorks MATLAB, or some other similar things like Maple or MacCAS, etc. And of course, nowadays it is a quite easier or much more smooth way to use some other platform like a Sage, which is called a Sage server. This has been inscripted here, Sage KNOU ACKR. So these are going to be good materials for you when you are continuing our these classes. As I have already mentioned, our online materials are also going to be appear in this type of a band, label band. So probably you have already witnessed, read my announcements like these things. And sorry. So I'm going to use this kind of band so much more free way. So later then you're going to use a much more interesting way. Here I would like to say much more brief pause. You may have a break, I mean. So I like to give you some advices like this. Engineering mathematics is mathematics. The classes of mathematics or subject of mathematics is something like a one type of learning process. When you are approaching the learning process, I think the curiosity is quite the most important thing. So they will give you some more chances to learn more. So please be curious and be alerted to curiosity. All right. Then we are going to start from our class. Maybe in this classes, actually, we are going to use this type of this type of textbook. Now, this is a 10th editions of Advanced Engineering Mathematics. So you can search out these textbooks. I think this is quite thick, so you may be very suffocated with this volume of these materials. But I think in our class, I mean our subject, it encompasses like 6 parts in this document, in the contents, but we are only focusing on the first part, part A. That covers with only differential equations. So probably it encompasses more than 25 or 6 chapters, but amongst that, we are going to touch with from 1 to 8 maximally. Maximally means not full. So for example, I really emphasize or focus on the chapter 1 and 2 and some part of 3 and 4. And then we are going to skip chapter 5, and then we are moving to chapter 6. Chapter 6 is the most important part of this full part of part A. Then chapters 7 and 8, I'll very briefly touch with that because they are much more leaning onto linear algebra, so that is the major part of this engineering mathematics syllabus in this semester. So for your much more interesting textbook or appendix, I'd like to suggest you to buy or rent a book or cartoon from the library or from the bookstore. You can buy this very brief one. But this is I say cartoon, but this has been very interesting materials which has been devised by Professor Cho Chae-kyung, who had served in Kyongsang National University for a long time, more than 20 years ago actually. So in every semester I recommend my Korean students to read this brief cartoon that is much more interesting to be acquainted or accustomed with engineering mathematics, especially on differential equations part. Okay, so what shall we start to learn? So from what we are going to learn? We are going to learn quite much through this learning process of engineering mathematics, but I think the most of the students should be familiar with what is math or what we are actually intending to learn mathematics for engineers. That is so important. So I rather emphasize function or equation. They are symbolic equations usually. So those symbolic equations, for example, y equal fx, this type of equation form or function, we call that as a symbolic equation. So this type of symbolic equation is so important because this is a meta functions, right? We don't know what is the x exactly, or what do you know what is y exactly. So anyway, they are the relations between y and x. So we call that y is called as a function of x. So anyway, y will be delivered a certain form of a variable x. So maybe maybe when you learn something, we must be much more familiar with some terms. When we say that y equals to fx, at the time we must understand what is meaning of how we call the y. Y is the value, and f is called as a function, and x will be called as a variable. Sometimes y or x, those are things could be used as a certain values. I mean, value means a certain exact number. I mean, value. So exact number we call as a simple number like an integer or real number. At that time, that is called just a number. But in the form of this function, those are going to be changed according to certain relations. So this is a stereotypical way how to write or read the mathematical equations. So we must understand these situations. By the way, we are going to say about the differential equation. Here, mostly ordinary differential equations, but this is also very, very important concepts. But sometimes if you are missing that, it's going to be troublesome, I mean. So we must understand what exactly function means. So at the time, we must say about the function. The function was, as I mentioned, this f is called as a function. So this type of a function. So at the time, as I mentioned, the y value will be related with x with a certain function of x. How x making a function, so the result will be y. So that is something like this type of explicit functions. So we call that y equal fx. That is like called as a symbolic expression or equation. I mean, so symbolic means written in symbols. So symbol means a certain alphabet, or yeah, even though we do not use the Korean characters in equation of, I mean, the function of equations, but for example, we can write down here h here equals to 기억 of near, something like this. But even though we are not so familiar with this type of formulations, but because this is not the general to the worldwide. So furthermore, almost all the equations or functions has been inherited from the Western society. So we have adopted Western things like y equals to fx, right? So for example, here actually we may say the whole effect. How we can say that a function derives some effect or effects in a certain variables. That is called as something we call that like this: integrations of fx equals to 1. It is a bit awkward though. It means something like this: a certain function of fx lies in some area, for example, in area like this. So if x is called in the axis of x, that x, according to the x, is something like a function of this. We have in the minus infinity until to the positive infinity. So integrations of all the values, that will be called as 1. 1 means 100%. So something like this. So actually, the people who are witness this type of equations or function, they are straight from the meaning. How because of they are very embarrassed with this symbolic notation. So, but they are not fully understand exactly though. But we must start what exactly wants to show here. So something meanings like this: the whole summations of the values. All values means here fx or y. Then whole values summated, then the value is 100%. So what is that? It's a quite simple question. If we summarize all the values which has been happen on Earth in anyhow minus infinity or to the positive infinity, then the full area at anyhow what had happened, they are going to be 100%. That has been happening in a way. So that is called the meaning of that function, this. So in some cases, this function will be generated with this function. Then fx is, y equal fx. Fx is the equations of this one. I'm sorry, not this. Then we'll say this is called y is the function of x with a bell-shaped. Bell-shaped means something like something 0 to x is going to be minus negative to positive. They are shaped the bell like this. So if it goes to the infinity, minus infinity, they are going to be 0. If it goes to the positive infinity, they are also going to be 0. In the middle, that center, then that is the maximum. So if that has been shaped, with this bell, then we call the bell-shaped function. So if you see these kind of equations, something like this, when you imagine like this or not, that is something like a drill. Experience or be familiar with that things. So this is important things when you learn something. So anyway, that is what I have said for. So here I said differential questions. What is the differential question? That is the question here. I say a certain function of y equal fx. Normally we call this function, right? We call it as an equation. Why we say sometimes we call function or sometimes we call equation. Equation is called with an equality. Equality, I mean this type of symbol, equality. Equality symbol that has been designed by this equality. So here, if there is something like this one, that we call inequality. We call that is not an equation. That is an inequality function. So most of the equation means which has been derived, which has been denoted by this equality. So then you must understand, right? Then what is the differential? So when you see that differential is called, you might have learned in a high school equation, high school mathematics. So something functions like a certain function like an fx prime. Y equal to fx. So if it has to be derived from that y as one prime, that is called as a first order derivative. We call it differential. If it is certain functions of something like this, but they are including some derivative, something like derivative like this, y equals to y1 prime or something like this. fx style is something like a y1 prime. That is the meaning of differential equations. Of course, we may have 2 primes or 3 primes, a first order equation or second order differential equations, derivative side. You have already probably remember something like this. This called as a differential differential or derivative, something derivative, I mean, this is a plural form, derivatives have been included in a certain function that we call as a differential equation, shortly differential equation, DE. Here y equals to y1 prime. That means y1 prime equals to y, same one. y1 prime minus y equals to 0. They are all same expressions. These are all same expressions. So we call these, maximally there is only one first order derivative. So we call this is called as first order linear differential equation, or linear means this is going to be 0. So anyway, linear form. And ordinary here, there is nothing, something like y1 prime times y. I mean y primes times y equals something k, something like this. That is, these are going to be called as I mean y, something like this. Then they will call or something like this. Then we call as a, if you maximally checked out this, going to be something like this, but something like this, y1 prime equals to k y squared, something like this, then or y1 prime or y2 prime, that has been multiplied with same derivatives more, then we call that not ordinary or maximally. So anyway, here, as we have seen this type of y equals to y1 prime, we call as first order linear equation. So here, I'm going to skip over this part. So I like to emphasize this part. In learning process, I emphasized it from the beginning. Learning process, even in the mathematics classes, we must learn terms and equation, or some terms will be incorporated in our notebooks into a glossary. So you must keep some notes. Keep notes are very important. When you keep keeping your note, at the time you must think of the words first, and how you can write it down or justify it in the mathematical forms. I mean symbolically expression. I mean expression. That means equation. I say equation. That is a type of expression, right? Expression or representation. And also, after that, some equation, what is the meaning? What's that? Well, these three types of pillar, if you are keeping on interest in the three pillars, what is the words, terms, I mean, in terminology, terms. What is the term and how you can write it down, especially in expression form, especially in the mathematical equations. That is a symbolic equation, I mean, equation. And sometimes, so of course, you must understand what is that exactly. Then at the time, you must have some physical sense or logical sense. Physically or logically, you must understand what that is. As I have mentioned that before, for example, as I mentioned here, something like this bell-shaped expressions, something mean better here. that has been going to negatively, positively. If it goes to 0, and in the center, that is maximum. That is called as a Gaussian or normal Gaussian. Gaussian equation. We often call it Gaussian probability distribution function. So with this type of equation, we may understand it. Oh, one more thing. This type of things, some function is called this way explicitly. Then we call it explicit equation, but this is called as an implicit. What is the meaning of that explicit or implicit? Explicit function means some function is written by this explicitly. I mean, on the other hand, this function is some relations after result that is the happening like this. What actions? Some integrations. So after the some actions which has been happened in total, that is the meaning. These things that is called, we may conjecture, or we may infer how it works in total. So as I have mentioned here, what has been happened in all the area. I mean, we call it in mathematically in some domain that has been happening fully. That has been full occurrence, 100%. I mean, so we call that as an implicit expression. Yeah, and yeah, here I would like to emphasize one another very simple one. Yeah, sometimes we may use special characters not geared to here, but we use alpha to omega because this modern mathematics has been imported from the Western society, so we have used their convention. They are using the A to the Z. Not only with this, because we have only 52 characters in this character set, so they sometimes want to use more, like the alpha to omega, 26, 24 more, and sometimes they are going to use the Hebrew alphabet, some other Hebrew characters. So anyway, on this book, this book has been very well prepared. This also covers from the cover to cover. We do not fully check it out, fully cover to cover, but here they are also check it out some appendixes like yeah, at the end of this cover, at the end of it. I'm not sure whether you can see that. Here at the end of the textbook, that also shows some charts like Greek alphabet, alpha, beta, gamma, and so on. Yeah, these are simple character sets, but you must realize to differentiate how they are different with each other. So sometimes you must cover up, check it out, the cover pages, front covers and the back covers too. So you must be very familiar with that character pictograms. So maybe it has been very tough for you for the first lectures, online class. So I'd like to pause here. One more pause, intermission. Please take your time and feel free to ask whatever you have encountered in questions. Then please send your questions on the band, as I mentioned here, band. Yeah, and also of course you have to write down your self-introductions. So that should be that is for our ice breaking between you and me, and between yourselves or students too. So we must be much more actively interact with each other. So please have a good break for a while.